Hi everyone, welcome to today's webcast. We'll be talking about how we can predict customer churn using Amazon SageMaker. I'm Sanjay. I'm joined by my colleague Robbie. We are data and AI consultants at Thorogood with experience working with multiple clients across varied domains like consumer product goods, insurance, and healthcare. Let's take a quick look at our agenda for today. We'll start with an introduction of Thorogood, who we are and what we do. We'll talk about customer churn, explore the benefits of understanding which customers are likely to leave your business and how this knowledge can drive decision making. We'll then demonstrate the process of predicting customer churn using Amazon SageMaker. We'll also see how we can use the model for our use case. We'll see how we can visualize customer churn and derive useful insights from it. Finally, we'll wrap up by highlighting how Thorogood can help your organization in navigating the complexities of predictive analytics and maximizing the value of your data. Thorogood is a global, independent data AI consultancy with offices in the US, UK, India, Singapore, and Brazil. We focus on helping our customers pair technology solutions with business problems across a full range of data and AI services. We are a technology independent firm, and so we partner with many of the large cloud and technology providers and platforms. We work with a number of large customers, and we tend to focus predominantly in the consumer goods, insurance, healthcare, and banking sectors. Let's now talk about customer churn. In any business, customer attrition is an inevitable reality. However, what sets successful organizations apart is their ability to predict and proactively address customer churn. So, why does it matter and what can you do? Firstly, identifying customers who are likely to leave empowers businesses to take proactive measures, addressing issues before they escalate. Retaining existing customers is often more cost effective than acquiring new ones. Marketing campaigns and operational costs aimed at attracting new customers can be substantial, making customer retention a strategic priority. Machine learning models can play a pivotal role in predicting customer churn. By leveraging predictive analytics, businesses can anticipate churn and intervene in a timely manner. AI-driven analytics enables organizations to identify common patterns in customer behavior. Understanding the factors contributing churn allows businesses to tailor their strategies accordingly. For instance, if a particular locality exhibits high churn rates, investigating potential shipping issues in that area can be instrumental in mitigating customer attrition. Let's look at some key considerations that are important for customer churn analysis. To effectively address customer churn, it is crucial to understand its significance within your business context. How do you define churn? What are the indications a customer is likely to churn? What is the nature of customer relationships, etc. When it comes to defining churn metrics, it is crucial to look beyond simple retention numbers. We can categorize churn into two different levels. The first level, it is basic level. Churn can be categorized as customers who either stay with the business that is in or leave. That's out. Now, beyond this binary in-out categorization, we can also consider the strength of customer loyalty. This involves assessing whether the customer loyalty is increasing or decreasing over time. It provides deeper insights into customer behavior and potential churn indicators. Let's look at an example. In a subscription-based service like Netflix, customers either continue their subscription, that is in, or cancel it, so out. Within those who continue their subscription, we can further analyze the engagement levels to determine whether the loyalty to the service is strengthening or weakening over time. Understanding the nature of your customer relationship is also important. We can assess this based on two key dimensions: discrete or continuous relationship. That is the interaction with your customer sporadic or ongoing? Is it a one-time transaction or a part of a continuous engagement? For example, take insurance contracts. These typically represent a discrete event. Each contract represents a distinct policy purchase, renewal, or cancellation. Therefore, in customer churn analysis for insurance, you would treat each insurance contract as a discrete entity. The churn event would occur when a customer cancels or does not renew the insurance policy. On the other hand, retail purchases, like purchasing shampoos, for example, can be seen as a continuous event. Customers may buy shampoo regularly as they run out of it, and there may not be a clear-cut start or end point for each purchase. So in this case, for customer churn analysis, we look at the customer behavior over time and look for changes in their behavior. Maybe they don't purchase for a prolonged period or purchase much more infrequently than they used to. The other dimension is contractual, non-contractual. Are there formal agreements or contracts governing the relationship, or is it more informal? With the same example, insurance contracts involve contractual agreements where customers commit to a specified duration of service. Retail purchases, on the other hand, are often non-contractual, allowing customers to make one-time purchases without any formal obligations. Understanding these nuances helps tailor retention strategies effectively, ensuring a personalized approach to customer engagement and mitigating churn proactively. For today's webcast, we're going to take the example of an auto insurance firm and help predict customer churn within that firm using machine learning. We're going to predict how many customers are going to leave in a 3-month period. The first step is data preparation. We start with an initial data set containing features and a label. Features would be different attributes of the customer and the label, that is the binary outcome, whether the customer has churned or not. For the auto insurance firm, the dataset contains details about its customers, including demographic data. Since we want to predict how many customers are going to leave in a 3-month period, we'll take a snapshot of the customer data from 3 months ago. The churn column indicates whether the customer has churned or not at the end of the 3-month period. The next step is data splitting. To assess the performance of our models accurately, we split our data randomly into training and testing datasets. The training data is used to train the model, allowing it to learn the underlying patterns in the data. The testing data is then utilized to evaluate the model's performance by providing predictions which are compared against the actual values. Machine learning is an iterative process. We continuously refine and improve our models by experimenting with different features, model types, and parameters. Techniques such as feature engineering, model selection, and hyperparameter tuning are employed to enhance model performance and accuracy. One commonly used tool for evaluating the performance of classification models is the confusion matrix. The confusion matrix provides a detailed breakdown of the model's predictions, including true positives, true negatives, false positives, and false negatives, enabling a comprehensive assessment of classification accuracy. There are a number of tools from different cloud providers which help us build machine learning model. In today's webcast, we are going to focus primarily on Amazon SageMaker. SageMaker is a managed service from AWS, which provides the tools to build, train, and deploy machine learning models. This platform automates the tedious work of building a production-ready machine learning pipeline. There are a number of tools that come with SageMaker. Two key ones are Canvas and Notebooks. Canvas is an example of an automated ML tool. It provides a user-friendly interface to do all the tasks which we discussed in the previous slide. With a few clicks, the user can pick a dataset, see what are the different columns, pick a target column, that is what you're trying to predict, and display what is the correlation between the target column and the other columns in the dataset. Canvas will automatically pick a model based on what you're trying to predict. That is it a quantity, is it a label, how many categories within that label? You don't have to worry about what is the underlying algorithm being used for prediction. Splitting the dataset into training versus test set is also taken care of by Canvas. The model is evaluated against the test dataset and key evaluation metrics are displayed to the user. The model can now be used for prediction. All this can be done without any programming knowledge. However, it lacks in flexibility. It is difficult to perform advanced data engineering activities. It is also difficult to explain the results. There is limited control on what algorithms are being used in the background. The alternative is SageMaker Notebooks. SageMaker Notebooks is an example of a custom coding machine learning application. Let's look at how to use SageMaker Notebooks for our customer churn use case. What was done automatically in Canvas needs to be programmed in SageMaker Notebooks. We can use a programming language like Python and leverage its rich set of libraries. We pull the dataset from a cloud service provider. In AWS's case, it is S3 or Simple Storage Service. The dataset we are using is from an auto insurance firm and contains information about its customers. We can see the different set of columns in the dataset and some sample data in these columns. We also have a column which says whether the customer has churned or not. We can see the correlation between this column and other columns in the dataset. Our goal is to identify who are the customers who are likely to churn in 3 months. For this, we'll take a snapshot of the dataset as it was 3 months ago. We have some columns like tenure, which indicates the number of days the customer has been with the firm. Since this snapshot is of 3 months ago, we need to adjust the columns like tenure accordingly. Based on columns like customer originating date, account suspension date, we can get a picture of who the customers were 3 months ago. We extract these customers from the dataset and in turn use these customers for training and testing the model. These are some examples of data engineering techniques that can be used easily with SageMaker Notebooks. We pick the appropriate algorithm for building the model. In this case, it is XGBoost. We do hyperparameter tuning, we build the model, and we deploy it. We can test the efficiency of the model using the test dataset. A contingency table tells us how the predictions compare with the actual scenario. Of the customers who have stayed, the model has correctly identified 92% of them. Of the customers who have left, the model has identified nearly 40% of them. Then we have the confusion matrix, which shows the true positives, true negatives, false positives, and false negatives. Using these different metrics, there are other metrics which we can calculate like F1 score, area under the curve score, precision, recall, and accuracy. For a customer churn use case, which of these metrics would you want to optimize for? What does it mean to have recall at a particular value or precision at a particular value? Robbie will be covering some of these details in the next section.
Okay, so as Sanjay said, he's shown you how to create the model using SageMaker. You've got the predictions as to whether customers are going to churn or not, but actually, how do you apply that to the business and how do you think about which evaluation metrics are most useful to your unique business use case? Let me start by talking about some of the resulting actions. So what you could do once you've trained your model and you've tested it to see that it's relatively effective, you can then actually look at feature importance of the model. So you can actually look and see, okay, of all the input features that we had, which ones had the largest influence on whether a customer actually churned or not. And then the ones that are more important, can we change them in some way to actually improve customer retention across the board? So for example, if marital status is one of the lower ones in terms of less influential, but maybe something like response time to email inquiries about insurance is much higher. So whenever that's long, customers are more likely to churn. You can then work to change your business to see, okay, can we reduce response times by 50% and then actually hope to improve customer retention across the board, because it seems to be something that's making customers stay or go. So you can look at that at sort of the overall customer base level, or for each of your individual predictions, for any customer you've predicted is actually going to leave, can you do some type of what I'm calling an intervention to actually encourage them to stay? And that intervention can take many forms, which I'll cover later on. But for now, I'm going to focus on this action. How do we maximize the effectiveness of the interventions that we're doing? There's two ways. One would be to intervene with more customers who are actually going to leave. And then the second one is to reduce the effort and cost that you're spending intervening with customers who were never going to leave anyway. And how you do that, you have to bring back up the confusion matrix here, I'm going to use it as a bit of a crutch to explain it. So this is where you put your testing results, and then you would use a lot of the values here to work out a lot of those evaluation metrics that Sanjay shared at the end of the notebook. So what you want to do in terms of the first one, intervening with more customers who are actually going to leave. If you look at the predicted side on the left, positive is actually predicting someone is going to leave in this case. So you want to predict as many positives where that's actually the case. You want to increase the number of true positives. If you want to reduce then the effort cost spent intervening with customers who are not actually going to leave, you want to increase the number of true negatives. So you don't want to be intervening with anyone where it's not going to have an effect anyway because they were going to stay. You don't want to be making that investment. But basically, it's a balancing act between you want to increase both true positives and true negatives. So, for example, your true positive rate could be really high if you just predicted that every customer is going to leave, but you don't want to intervene on every customer because there's probably going to be some cost to that. If it was just an blanket email to everyone, maybe there's not so much cost and it's okay to reach out to everyone, but you want to be a lot more nuanced as soon as your intervention has some type of limit to it or some type of cost attached. And I'll get into that in a bit more detail and explain that a bit further. But basically, in summary, better your model, the more correct interventions that you're going to have. And by correct interventions, I mean actually intervening with people who are going to leave. So you may think, okay, you've said the better the model, the more effective it is. How do I actually go about that? Does that mean we should focus on, say, F1 score and make sure it's always over 75%? And while that's not a terrible way to go about things, in my opinion, it's not that simple, and you have to actually apply the business lens to the problem to understand which evaluation metric you want to maximize. So the key question at the heart of it really is, are my predictions of customer leaving, are those predictions effective enough to give a strong enough return on the investment that I'm going to have to make through the interventions that I'm actually doing? And basically, that is the revenue gained by intervening going to outweigh the actual cost of intervening? So the revenue is going to be some function of precision, which I'll come back to. It's one of the metrics that Sanjay showed, times by the number of interventions, the rate at which the interventions are effective, and then times that by the customer value, or customer, in this case, I put LTV because it's actually lifetime value. So it's not just in the auto insurance demo and use case, it's not just the value from their business of one more year, but actually it's the lifetime value. So if I can get a customer to renew for one more year, they're suddenly way more likely to renew for a second year and then hence a third year and so on. So there's actually a lifetime value to that. Obviously, the value drops, the expected value drops as you go further into the future because they're more likely to have left as a customer. But the customer lifetime value is the key upside here. And then precision is actually true positives over true positives plus false positives. So it's basically out of every customer that I've predicted or that Sanjay's predicted is going to leave, what percentage of them actually left? And then the cost is going to depend really on the method of intervention, and I'll talk about those in a second, and the number of times you do that as well. Some examples of the interventions, so you could have a call or a visit from a sales agent, you could switch someone to a plan that suits them better, You could offer some type of incentive to renew. So renew your car insurance for 1 year with us. We'll give you a 20% discount, or I don't know, we'll give you a free gift, say free headphones up to the price of, I don't know, 100 Sing dollars, something like that. Or, so those are all sort of insurance use cases. But if you work in, say, pharma or medical devices, you could like invite healthcare professionals to a product seminar or to a conference or something like that. And there probably are even further interventions you could do if you're, say, like a consumer goods customer, in terms of like the retailers that you're dealing with, or even some type of, if you're able to reach like directly to your consumers as well. So there's many types of intervention that you can actually do. And then just to expand on one of those with an example to explain the return on investment stuff I was talking about, say using Sanjay's insurance demo. So say we have a call center team who can make 100 calls a day. And before we were predicting any customer churn, they were just reaching out to customers randomly. And so the chances of them speaking to someone who was going to leave in the next 3 months is just like what percentage of customers leave on average in the next 3 months. So let's say that's 20%. Say, yes, we'll gain some new customers, but over the next 3 months, current customers as of today will lose 20% of them. If they're just calling people randomly, that means every 1 call in 5 is going to be useful where they're actually speaking to someone who is going to leave. So they make 100 calls a day, only 20 of those are going to be to the right people. Whereas if you take Sanjay's model and Sanjay's results, if we got our call center agents to reach out to still 100 people a day, but they only picked from the people we've predicted is going to leave, our precision on that was around 50%. So suddenly now 1 in every 2 calls is useful. And suddenly that team is calling 50 people a day who were actually originally going to leave. So you can see how actually a precision of 50%, it's really relevant as to how good that is compared to what you were doing before. Obviously, the higher that is, the better. And I'll explain how you could improve that model in a second. But that's the key thing, is sort of what were you doing before and what are the business interventions and what's the return on investment calculation. So if you think about, suddenly we're calling a lot more of the relevant customers, assuming our call center people will have some effect on them, we're going to gain revenue from that. And then if you compare that with the cost, the sort of marginal cost is no different because they were calling people anyway. So this is a pretty simple return on investment calculation. It would complicate it a lot more if the cost was a lot higher. So for example, if you looked at incentives, if you did offer free headphones to like the people that we were predicting were going to churn, you need to look at the revenue from the people who were going to leave, who took you up on the offer. So we're going to get revenue from them minus the cost of having to buy or give them earphones. But there's also the cost of you offering headphones to people who were never going to leave in the first place as well, even though you predicted them as positive as going to leave. So you have to consider the overall cost of all the headphones you got, plus then just the revenue from the few people or the smaller percentage that were actually going to leave originally. So it's just a more complicated return on investment calculation as soon as you're increasing the cost of what you're going to do in terms of intervention. So as I said, our interventions are going to be much better if our model and our predictions can be better. So how do we do that? Biggest way is going to be by getting better data in there. Can we add more data to our training data set to improve the precision of the model? So if you think about Sanjay's demo, the data set had tenure, county, a few other demographic things, but really the only one relating to like the customer behavior is tenure. It's just how long they've been our customer. The rest is demographic stuff that maybe doesn't vary that much. But whenever we've actually been working with insurance customers, they've been able to provide data that gives much stronger indicators of customer behavior. And that would be the likes of claims history of the customer, response time to their inquiries, time to pay out to the customer if they do make a claim. Have they reached out to customer service complaining before? What are the number of touch points they have, phone calls, web chats, portal logins, if you have a portal? And really that can depend. So some of the insurance customers had these, they had more as well. And the different types of customer behavior indicators you have are going to depend depending on the industry you have as well. For example, if you're talking about healthcare industry, pharma, medical devices, and another touch point would be someone going to one of those product seminars or conferences or something like that. So that's a way you can really improve the precision of the model, improve a lot of the other metrics as well. What we find is more customer behavior stuff you put in, the better results you're going to get. Another way of improving the model, less in terms of more accurate predictions, is more just expanding the model time horizon. So increasing the amount of data points that it's actually outputting, the amount of information across time it's actually giving. So if you think about what Sanjay showed, his model was predicting, will a customer leave in 3 months? Yes or no? Really useful for the short term, tells us who we should intervene with, particularly for those that we predict are going to churn. But actually, if they aren't leaving, does it mean that the customer, so if the customer's been marked as not going to leave, does it mean that they'll leave in 3 months and 1 day? Or does it mean they'll not leave for 30 years? The model doesn't really tell us. So what you'd want to do is actually rerun the same model, different inputs in terms of time horizon, but rerun the model to get 3, 6, 9, 12 months, much longer into the future, to build up a much better curve of overall customer retention across all customers, and be able to understand at what point is a customer most likely to try and leave. The other thing you can do is increase sophistication of the model type. So you could use models such as Cox proportional hazards model to create survival curves, rather than doing multiple XGBoost yes, no for different timeframes. There's multiple ways you could sort of add complexity and sophistication to that. The final thing to consider when you're talking about a business is, how do you share the model outputs with the business for their analysis and for their actions in a clear and informative way? One of the options is Power BI dashboard. So in this case, Thorogood is the insurance company. We're predicting customer retention for the next year. We're an insurance company. Here's some context on our current customer base. And then if I'm, say, a sales agent or a call center agent, and I manage all our customers from Denton County, I can see, okay, 3 months into the future, what are the predicted number of customers leaving? 1,000. Okay, what about 6 months? 1,400. So the number is sort of, it's not doubled. And then what we can actually see is the different curves as well. So here we've split it up by age group, and we can see what percentage of our overall customers have we retained at each time period for each age group. So you can see that actually the 30 to 50 here are most loyal up until the sort of 12-month period when our 18 to 30s catch up. So I don't know, maybe that's the sort of older generations are, a fewer number of them are actually driving. So rather than leaving to a competitor, or they maybe just stopping driving, don't need car insurance. But that's sort of the overall analysis you can do. You could add drill downs to that if you wanted. You could cut the data by different metrics rather than age group. And then if you think about the call center example I gave, you could provide top 10 customers likely to leave or top 500 customers likely to leave, whatever number. And then these could be the people that they reach out to. And actually in our model, it gives a yes or no, will they churn, will they leave? But that's based on a prediction probability and a threshold that we set. So actually what you can do is work your way down the list, and you could go, okay, well, I'm going to start with the most likely to leave and call them first, then call the next one second. And that's going to increase the precision of your actions further, I should say. The model would remain the same, but you're more likely to be speaking to someone who is actually going to leave, whose mind you can actually try and change. So that's just a really quick view of what you could put up in terms of analysis, but also in terms of giving them a list of people that they should action and intervene on. So we've shown you how you can build up that model and then how you can apply it to your business. That's where Thorogood can really help. So we can try and understand your business and understand your goals for customer retention. The key thing we try to understand is, like, what's your relationship with your customers? So that was an auto insurance demo, but the sort of relationship is going to change massively if you're in, say, consumer goods or pharmaceuticals, where you're probably dealing directly with retailers in consumer goods case, or direct with healthcare professionals in pharmaceuticals case. And then even in terms of if you can get to the end consumer, it's not that sort of discrete contractual relationship the same way in insurance. It's more continuous, non-contractual. You don't have the same confirmation. So how can we understand your business, and then how can we adapt the technologies and the ML techniques to that? We would also review your data as well to understand what data you have available and whether there's sort of more data we can acquire to help this use case. And by looking at all of that, having our consultants look at sort of the whole picture, we can generate what the opportunities are for your business in modeling customer retention. And then we can give that a go. We can, across the space of a matter of weeks, we can build up an experiment, a proof of concept on your data to see if you're getting good predictions. Then if you're getting good predictions on who's likely to churn based on sort of historical data and scenario modeling stuff, then we can actually build a productionized solution that actually integrates with your data architecture, build something where the business can access the results, sort of maybe the Power BI dashboard or something else. We could also ensure the model is retrained and kept up to date with latest market conditions and customer behavior, ensure we're using the optimal model type as well. All of that would be using Thorogood's extensive MLOps experience. And then finally, once you've got that fully sorted, how can you expand this machine learning solution? So what we've seen with a lot of customers is they want to first work out, okay, who's likely to leave or who's likely to reduce their number of orders or something like that. But then how can we use machine learning to actually predict what is the action, what's the next best action we can take with that customer based on similar customers historically and what they've reacted to. So you can even add that next layer of like, which of the interventions you should actually take. Or there's any number of ways to actually expand the machine learning model or automation side of things as well. So if you are interested in any of this, please do get in contact. My details are up there. Sanjay's details are up there. We'll respond to emails. Add us on LinkedIn if you want to connect, but then reach out sometime in the future. Very happy to do that. But other than that, thank you for joining and have a great rest of your day.